Hello and welcome everyone to the IXIA and You Nuggets. These are no frills, straight to the point videos for an engineer in a hurry. For those who don't know me, my name is Chris Gabrielson, and this particular video is going to be focused on using IXLoad to simulate real DHCP clients that can actively go through the DORA process. So that's discover, offer, request, and act. But they also have the ability to do some additional activities, like not only can they bind an address, but they can release, renew, or even send a DHCP decline if for some reason there's a conflict. So essentially anything a normal user could do, we can get IXIA to simulate. Our use cases for this sort of thing are obviously if we need to test a DHCP server that's running on a switch or router, or if we want to test the DHCP relay function, this is a great way to do it. It's also very useful if you need to test features like dynamic ARP inspection or DHCP snooping, where we have real clients which are associated with the network that populate things like device tracking and DHCP binding tables, that sort of thing. So if you need actual traffic to populate those tables, this is a great way to do it. Now, one quick gotcha before we begin is that it's important to note IXIA's IXLoad will be doing the client generation only. We do not have the ability to create a server within IXLoad. So what I've done is on my switch over here, if I look at the running config, I've created just a very simple pool. Now, obviously, one of the other things you could do is create a pool on an upstream device and configure a relay agent here. But for now, this is just a basic pool where my traffic is going to be in the 100.0.0.0 network range in a /8, and the switch has an IP address of 100.0.0.1. Another gotcha here, especially if you're using IXLoad, do not use an IP address of 10.0.0.1 or anything in that subnet, really, because that is one of the internal addressing schemes of the IXIA, and so it will cause your traffic to fail. It won't actually start, so just be aware you need to use a slightly different subnet. Now, with that being said, my IXIA port is connected on port gig 101. And it says here that this is IXIA port 11.1, and this is just a straight access port on VLAN 100. So plain untagged traffic. This switch will then hand out addresses, and if I look at show IP ARP, we'll see that right now that's empty. I've also got show MAC address table, so no MACs are currently being learned, and I've also got, if I were to do show IP DHCP binding, I don't have any traffic. So basically my switch is completely blank at this point in time. Now, hopping over to my IXIA, when you start IXLoad, it should bring you to this particular screen. And so the first thing I'm going to do is make sure I'm on the originate over here, and then I'm going to right click in this area and do add network traffic. Now, at this point, the application will always freeze for about 10 seconds or so. Don't worry, that's normal, happens all the time. After which, then subsequent times you click it, it should be just fine. Now, even though I'm about to add DHCP traffic, IXIA is a little funny in that it still wants you to define a network address range. So I'm going to click network 1, and that's going to bring up the config over on the bottom here. There we go. So now I need to set it for the address range that I expect. So this is going to be 100.0.0.2 with a mask of /8. I'm going to increment by 1. And for my count, let's go really big because I have a /8. Let's do 10,000 clients. And I'm not going to specify an IP for now. If for some reason you were testing with .1Q tags, maybe your traffic was tagged, over here with VLAN enabled is how you would do that. And then your first VLAN ID would be set to whatever tag you want to use. Your increment and VLAN count would both be 1, because you're essentially saying, I just want one VLAN. If you wanted more than one VLAN, you can adjust your increment value. So if you wanted VLANs 10 and 20, you would do VLAN enabled. You would specify your first VLAN as 10. You would increment by 10. So now if your counter was 2, the first one starts at 10, adds 10, so the next one is going to be 20. But for now, I don't care about that. I just want plain untagged traffic, so I'm going to leave that empty. Now, going back to where it says network 1 here, I'm going to mouse over traffic 1 and hit the plus arrow. And I'm going to open up data. And then if we mouse over DHCP here, we could see we have the option for a client, but no server. So IXLoad does not do DHCP servers. IX Network does, which I'm not going to cover in this video. But for now, we're looking at just the client portion. So if I click client, I now have my DHCP client here, and I can click this to modify what my client is going to do. And we have that setting is going to be right here between the start and stop. The most simple thing that you can configure is just hit this green arrow and hit bind. And this is actually going to be a macro where if I hit add for bind and mouse over, we could see in the little pop-up, it says that this executes a DHCP discover, a request, and if necessary, it will also do a DHCP decline. So essentially this is multiple commands all at once. And here we're going to act like a real client where we just respond to the first DHCP server to respond. Now, if you needed a bit more granular information, you could do that here. And this is where we see things like I can add individually a DHCP discover, or I could do things like a DHCP inform or release. I can also introduce the concept of loops or even thinking. So if I wanted my customer to come online, get an IP address, which they're doing here, I can then tell the IXIA I want them to now think. And I want them to think for, let's call it 10,000 milliseconds. So that'd be 10 seconds my user thinks after getting the IP address. And then they could do maybe a release or a decline or something else. And I can add that here. And now they will release whatever IP that they've been given. But in this case, I want these clients to hold on to this. So I'm just going to right click this and remove the command, right click, remove command. So now my clients will come online, they'll get an IP address, hold on to it, and then they will stop. So there's a lot of flexibility here if you need to configure it. But for now, again, we're just focused on the bare bones minimum. Settings you should not need to modify, but just in case, if for some reason you need to modify your L4 port numbers, timeout values, expected options values, maybe you're testing a specific option within DHCP, this is how you could do it in order to make sure you get it. But again, I'm just making sure that my clients populate the switch's binding table. All right, so at this point, we've now got our traffic profile all set up. Now we need to associate it to a physical port that IXIA will be sending this traffic out. And for that, I'm going to hop over to ports here. And within my Kalo case, I could see here I have two ports, 11.1 and 9.16. I'm focusing on 11.1 right now. And this is the chassis IP that we're going to be using for port 11.1. So I'm going to copy that IP address. And under ports here, I'm going to add chassis up at the top, this green plus. I'm going to paste in my chassis IP. Now, one of the prerequisites that needs to happen here, if you're familiar with IX Explorer, you can take control of individual ports. If for some reason someone else has control of your interface, that will not work here. And I'll show you what I mean in just a second. So let's get rid of slot 2, 3, 4, 5, 6, 7, 8, 9, 10, there we go. All right, so right here is port 11.1, and we can see that for port 11.4, there is a user ID associated with this. If there is another user associated with your port, you must clear it out first. It needs to be blank, just like we see here. There's two ways to do that. One, we have a clear ownership button up at the top where my mouse is, or I can simply right-click, and we should have an option to clear ownership as well. So if for some reason you've now associated to your client, which the way I did that, I'll back it out real quick. Make sure you have your scenario and your client traffic selected. So right now, traffic 1, network 1, then I have my port. And when I click those, I hit the green arrow. It now associates that particular port to my client. And again, I could right click, I can clear ownership right here, clear ownership and reboot port. So if there was a username associated with that, I would select this option. And it takes about a minute or two before it goes back to being green, but just be aware that's how you would clear it out if you don't want to log into something like IX Explorer. All right, so now I've got my scenario set up. I've got my ports set up. Now we need to define the timeline and objective. And we could see here a bit about what IX Explorer is trying to test. So for DHCP, we only have two real objectives. One is the number of simulated users that we would like to replicate. The other type of test we could do is transactions per second. So if you're doing some sort of performance testing and you want to prove that your server or switch can either relay or hand out maybe 1,000 or 100 transactions per second, we would choose that. But for me, I'm really just focused on the sheer number of users. Maybe my test is just trying to build the table for snooping or something else. So I have simulated users. I'm going to bump up my objective value here. I'm going to add some zeros. So let's do 10,000 users, which is the same number that I configured on my originate back here for network 1. Very important, make sure that the number of users that you are specifying here is at or higher than your timeline and objective. So if your objective says 10,000, but that previous value says 100, it's not going to work. So with that being said, I've got my objective value of 10,000. Let's now talk about this little graph out in the middle. This defines how IXIA is going to set up this test. And the default value is to have one user per second come online. And with 10,000 users, that means it'll take 2 hours, 47 minutes, and 20 seconds for all 10,000 users to hit the switch. Which, if I'm just trying to get a very large binding table, that may not be ideal for me. So what I could do is I can change either my ramp up value or my ramp up interval. So instead of 1 user per second, maybe I want to do 25 users per second. I'll move this up right here. So this is what I'm changing right now. Ramp up value is 25. We have options as well, so max pending users, etc. So if I just want to see however fast the switch can handle it, I could just do a ramp up value of 25 and it'll just try as quickly as it can to hit that 10,000 with no more than 25 pending at a time. But for now, maybe I just want to do users per interval. I want to do 25 per 1 second interval. That's what it's doing now. And so if I were to look at what this test is going to do, it's now going to take 7 minutes and 20 seconds. Or really, it's a little bit less than that. But it'll take about 7 minutes now for all 10,000 users to come online. The sustain time is how long we will keep all 10,000 users active. And the default is 20 seconds. I'm going to change that to 5 minutes. So now I'll take approximately 7 minutes, a little bit less than 7 minutes, for 10,000 users to all get an IP. They'll then keep that IP for 5 minutes. And then the IXIA generator will now take 20 seconds to gracefully close all those connections out. And maybe I just want to bump it up. Let's make it 1 minute and 20 seconds. And now that's going to be the complete testing cycle. We'll have 10,000 users come online, trying to get an IP address at a rate of 25 users per second. It'll continue to grow until finally all of them have the IP. We'll stay there for 5 minutes, and then we'll take the next 80 seconds to gracefully close all those sockets out. Now, once this completes, that'll be the end of the test. But if I want something where maybe I'm cycling through this multiple times, maybe it needs to last multiple hours, then I can change the number of iterations here. So if I want to say something like 75 iterations, it'll now do this entire 13-minute test 75 times in a row. So that's a great way if you just need to make persistent traffic that lasts a few hours or a few days, just bump up your iteration times. All right, so now let's review. We've got our scenario defined. We've got a network with a large number of users. So in this case, we have a count of 10,000. We have a DHCP client. We've configured all the default values here, and we just set up a simple bind operation where the client's going to come online, do a discover, get an offer, send a request, and consider it done. And then we've also got within our ports, we've associated one physical interface from the IXIA to be our DHCP client. Within our timeline and objective, we're now going to try and simulate 10,000 users who come online at a rate of 25 per second, and we expect that to take about 7 minutes before topping off at 5 minutes where we keep all 10,000 active, and then we're going to gracefully close it out. our test is now ready to begin. So the way we do that is we're going to hop up to the top left-hand corner here where it says Start Test, and I'm going to select Test 1. Now down here in this area, we're going to see a lot of stuff scroll by, and I'm not a big fan of the way IXIA reports some of this stuff, so just be aware if you ever see the term test is unconfigured, it means that something has failed and you got to scroll back through this entire thing, see if you can reverse engineer what was going on. But if it's successful, we should see what just happened here, where it now automatically switches over to the Statistics tab, and we can see that there are a lot of different views that we can look at. And it typically takes a minute here to get started. But if we were to look at this, so the way this is working is we have here our simulated users, and the count of simulated users continues to go up. But if we look at our transaction rate, we could see it's a little sluggish at first. Just be aware, IXIA it's not super real-time reactive. But this is essentially what I want to see. So we started off with a lot of users, nothing was really happening. Then the transaction rate suddenly bumped up, and we could see now a bunch of them started getting some addressing information. If I want to add additional objectives, or if I want to look at additional values in terms of what might be going on, I can add that here. So I can look at from my client here, I can see, okay, what's the current count of DHCP discovers that's going on? And we could see that we've sent 15,000, of which 13,000 were successful, so they're a little bit different. They're kind of proportional here. It looks like at the very beginning, things weren't working. The way we read this graph as well, so the simulated users continues to go up, and the transaction rate, because we're adding exactly 25 users per second, this transaction rate is holding steady relative to the 25 per second. That's why it's going across like this. But this is a good sign. It means that our commands are actively working. And I can uncheck some of these and kind of modify some of the values here. So let's see if we could let's look at failures. So we could see that there was couple failures, not a whole lot here. If I look at the discover rate, I could see kind of lots of successful commands. Let's hop over on the switch and see what's going on. So if I go show IP DHCP snooping binding, I can see there is a large number of clients that are now being created. In this little timer here, we could see they're all fairly quick. So if I look at, I think we have count. No count. So let's do a pipe count for automatic. There we go. So I could see here, right, this is going up by approximately 25 per second. So the switch can easily hand out 25 addresses a second. As fast as IXIA is sending them, we're allocating those addresses out. And if I look at my show MAC address table, I can now see the exact same number of MAC addresses in VLAN 100 is being populated here. And if I look at show IP ARP, I now have ARP entries as well. And these are all just a couple minutes old because that's what's happening with my clients. These are all happening pretty much real time. And at a high level, that is how we set this up. So a couple things to be aware of. Again, as we said, we can modify all of these values here if we need. We can also see kind of, what's going on. There's lots of different options here. These are very useful if you ever want to take a screenshot, maybe show a customer, show them, hey, here's what I tested. Here's the success rate versus errors versus whatever. So very flexible in terms of what we can report. And then if for some reason we need to stop this test, so I'm going to go ahead and let's go ahead and just keep it as these two. So here's my test objectives. If for some reason I need to stop it, or maybe I need to modify the test, we can hop over to config here. And if I click stop test, I have two options, just straight up stop or a graceful stop. One should, if you have anything like TCP or DHCP, it should gracefully kind of stop all the sockets, as opposed to just stop test, just straight up kills it right then and there. So I'm just going to go ahead and just do a graceful stop, and it'll take a minute here, but eventually this will now stop. And if you want to modify anything, so before we were doing simulated users, if I wanted to, let's see, I think it's still trying to stop. Yeah, so It's going to take a minute to stop. All right, there we go. So right here, we could see it was gracefully kind of taking our users offline, bringing the connections down. So at this point, test is almost done. Our users are kind of finishing up here. And then once this gets down to 0, we'll see where it says test is running. We'll see that say test has stopped. So almost there. I think we're just about there. So, okay. So once we have the test is officially stopped, and right now it's taking a little bit too long, so I'm just going to go ahead and stop it forcefully. Great. Now I could start modifying things like max pending users. And so with this, we could say, all right, let's see how quickly, we can get this to run. And so if I start my test, it should be a lot quicker in terms of not only pushing the configs and hopping over to statistics, but it should be a lot quicker in terms of my binding allocation as well. So here we can see it moved a lot quicker to statistics, gives me some base values here. These are obviously historical. They're all going to be refreshed, and now IXIA is going to go basically flat out same thing. We're going to see how quickly we can get a lot of these addresses set up. So right now, my total user count, we could see IXIA, rather than just having a steady line going up, IXIA with the blue line here is now kind of figuring out, based on the transaction rate, how quickly we could do this. And one kind of thing to note, especially if you're doing any sort of performance testing on a switch or router, be aware IXIA is kind of sluggish, meaning it might take 30 or 40 seconds for it to kind of start at one value and then realize it can go even faster, and then it'll kind of tick up and kind of change its trajectory a little bit. But otherwise, this is kind of how we can use IXIA to simulate DHCP clients. So I hope you found this tutorial useful, and feel free to reach out to me with any ideas, suggestions, or if you get stuck. Thank you, and have a great day.